Welcome to my channel. If you like my videos, then kindly subscribe, like and watch. Thank you.
Welcome back. Problem 9.12. Clear? So the statement of problem is that for the beam and loading shown, here the beam is AB and there is a uniformly increasing load given. Express the magnitude and location of maximum deflection in terms of W0, L, E and I, and B part is calculate the value of maximum deflection assuming that beam AB is W18 by 50 roll shaped and load and the length is also mentioned. So let's start with the given data. So from given data, it is given as beam AB is W18 by 50 roll shape. Also W0 is also given as 4.5 kips per foot. Clear? Length of the beam is given as 18 feet. Clear? And E is equal to 29 into 10 raised to the power 6 psi. Clear? So in part A, it was given that express the magnitude and location of maximum deflection. So again you have to find location. By location we mean the value of x along the x length of the beam where the maximum deflection will occur. So we will find location xm and maximum deflection as well at this location. And in part B it has been asked calculate the value of maximum deflection. So value of maximum deflection in terms of numerical value, where here you have to find xm and ym in terms of W0, L, E and I. So let's start with the solution. So for first step of solving this problem is that you have to draw the free body diagram of this beam. So let me draw this free body diagram of this beam. That this is beam, this is point A and this is point B. So at point A there is a pin support, so we will remove it and there will be a reaction force, and again at point B there will be a reaction force B. Clear? Now you can see that this is a uniformly increasing load. Clear? So this is W0. So again, in order to convert this uniformly increasing load into concentrated load, so you can see this is a triangle. So area of triangle, or this conversion of this load into concentrated load, is 1/2 area of this triangle. So 1/2 W0 into base is length. So W0 is height and base is length of this beam. Clear? So this W0 is converted into concentrated load and this will act at a distance of L by 3 and the remaining distance will be 2L by 3. Here, so I will mention this load over here. So let this is the load and this is 1/2 W0 into L, and this is acting at a distance of L by 3. This is total length L. Clear? So what you have to do, you will use this beam as a free body diagram and you will find the unknown reactions. Clear? Okay, so using equilibrium condition, we have sum of all forces along y direction is equal to 0, and there is another equation, sum of all moment is equal to 0. We will use this equation in order to find the reaction force A and B. So from first equation we can see RA plus RB, because these two reaction forces are upward minus 1 over 2 W naught into L is equal to 0. So it means that RA plus RB is equal to 1 over 2 W naught into L. Clear? Now we will use the second equation, sum of all moment about any point is equal to 0. So we will take point B. So sum of all moment about point B is equal to 0 and counterclockwise is positive. So you can see that this at moment about point B is due to a force RA into perpendicular distance L. So RA into L, and as it is producing clockwise rotation about point B, so it will be minus. Clear? Plus this moment due to this load, concentrated load, so it will be equal to this load multiplied by L by 3, and it is counterclockwise, so it will be positive. So 1 over 2 W naught into L into perpendicular distance is L by 3 is equal to 0. So when you solve this RA comes out to be 1 over 6 W naught into L. Now you have RA as well. You can put the value of RA and you can calculate RB as well. So now let's move forward. As for finding the slope or deflection, we will use this equation EI into d square y over dx square is equal to moment. Clear? So we will find the moment for this beam. Clear? And what we will do is that we will cut it at this point, and this point is at a distance of x from point A. Let me draw it as well. Clear? So this is the beam. Clear? This is the reaction force RA. Clear? And this is the load, uniformly increasing load. Clear? Now when you cut it, there will be a shear force and as well as moment at this point, and this point is J, and this distance is X. Now for whole beam the load was W naught. Let me show you. This is for whole beam, this is W naught. Now as it is acting at X, so this load will be equal to Wx by L, W naught into X by L, because it is acting at X distance of total length L. Clear? So again we will use, for finding this moment, we will use sum of all moment about point J is equal to 0, taking counterclockwise as positive. So you can see at point J there is a reaction force, and RA is 1 over 6 W naught into L, and perpendicular distance is X. Since it is clockwise, so it will be negative. There is a reaction moment. This is X. There is a reaction moment counterclockwise, so it is positive. Now due to this load W naught into X over L, that if we convert it into concentrated load, so again this is a triangular load, so it will be equal to convert it into load, it will be equal to W naught into X over L, and it will acting at X over 3, because here the distance is X, where above you have L, so it was at L by 3, so here it will be acting at X by 3. So their sum must be equal to 0, as it is also producing counterclockwise, so this value will be also positive. Clear? So again when you simplify this, the moments comes out to be 1 over 6 W naught Lx minus 1 over 6 W naught x cube over L. So this is the moment equation which we will use in above equation that we have written. This is the equation. Clear? So you have to put this equation in this equation. Clear? So we will get EI into d square y over dx square is equal to 1 over 6 W naught Lx minus 1 over 6 W naught x cube over L. Clear? Now let this is equation number 1. So integrating equation 1, we will get EI into dy by dx is equal to, this will be 1 over 12 W naught Lx square. So it will be equal to 1 over 12 W naught L x square, and it will be 1 over 24 W naught x4 over L plus C1. This is equation number 2. Again integrating equation 2. Why? Because we want to get the equation of elastic curve or equation for finding the deflection. 2. So we will get EI into y is equal to, this will be 1 over 36. You must know how to take the integration x cube, and this will be 5 power, and below is 5 into 24. Clear? So it will be 120. So it will be 120 W naught x5 over L plus C1x plus C2. Now C1 and C2 are unknown constant of integration. So in order to find this, we will use the boundary condition. So what will be the boundary condition? Let me show you the beam. So you can see both ends of the beams are supported. So at x is equal to 0, y is equal to 0, and at x is equal to L, again y is equal to 0. So these are the boundary conditions that will be used below to find the C1 and C2. So first boundary condition is at x is equal to 0, y is equal to 0. So put in equation number 3. So when you put x is equal to 0, y is equal to 0, so again you can see that this y will be 0, this x will be 0, this x will be 0, this will be 0. So C2 is equal to 0. Clear? Second boundary condition is at x is equal to L, we have y is equal to 0. So again put in equation 3. So when you put x is equal to L, y will be equal to 0. So this term will be equal to 0. This will be equal to 1 over 36 W naught L 4. This will be minus 1 over 120 W naught L5 over L plus C1 into L, and C2 is equal to 0. So when you solve this, C1 will comes out to be minus 7 over 360 W naught L cube. Now you can put the value of C1 and C2 in equation 3 in order to get the equation of elastic curve or equation for deflection. So put C1 and C2 in equation 3. So equation 3 become equal to y, and again divide both sides of this equation by ei. So you will get y is equal to w naught, clear, take the w naught as common, ei, and this equation will become equal to 1 over 36 L x cube minus 1 over 20 x 5 over L minus 7 over 360 L cube into x. Clear? So this is equation of elastic curve, is required equation of elastic curve, where y is deflection and x is the location from 1 and A. Clear? Now you can see that in first part we have been asked to find the location for maximum deflection. So maximum deflection, at maximum deflection slope will be equal to 0. So we will take the derivative of this equation. So dy by dx is equal to w naught over ei, and when you take the derivative of this, so it will be equal to 1 over 12 Lx square, and it will be minus 1 over 24 x4 over L, and this will be minus 7 over 360 into x. Clear? We have already told that at point of maximum deflection slope will be equal to 0, so put dy by dx, then that is equal to dy by dx is equal to 0. So when you put, so this will be w naught over ei into this term 1 over 12 Lx square minus 1 over 24 x4 over L minus 7 over 360 into, this is L, sorry, this is L cube, this is L cube, this is L cube. So this L cube is equal to 0. As this term is not equal to 0, so okay, so the product of these two is equal to 0. As w naught over ei is constant, it is not equal to 0. So this term, only this term is equal to 0. So I will write 0 is equal to 1 over 12 Lx square minus 1 over 24 x4 over L minus 7 over 360 L cube. Clear? Okay. So now if you look at this equation, so you have to take the LCM. There LCM is 360L. Clear? So when you divide this, it will be 30 L square x square. Clear? It will be minus 15 x4 and minus 7L cube is equal to 0. So we have this equation 30L square x square minus 15 x4 minus 7L cube is equal to 0. So it means 15 x4 minus 30 L square x square minus 7 plus 7 L cube is equal to 0. Clear? Now if you take this as 15 x square whole square, 15 x square whole square minus 30 L square x square plus 7L cube is equal to 0. So it is a quadratic equation where we have a is equal to 15, b is equal to minus 30 L square and c is equal to 7L cube. Clear? So you can use the quadratic equation. I will just write the short because it will be lengthy further. So xm whole square will be equal to 0.269 L square. So further, if you take under the root, so xm will be equal to 0.5193 L. So this is the location along the length of the beam where the deflection will be maximum. Clear? Now we will put this in this formula, that is equation of elastic curve, or for finding the slope. So when you put this x is equal to 0.5193, clear? So you will get the maximum deflection. So W naught over EI into 1 over 36 L. In this x we will put this value. So x is 0. I don't know why this is happening. 0.5193 L whole cube minus 1 over 120, 0.5193 L whole 5 divided by L. Clear? Plus minus 7 over 360 L cube into 0.5193 L. So when you multiply and further simplify it, so you will get ym is equal to minus 0.00652 W naught L4 over EI. There. So this is the deflection in term of W naught, L and E and I. Now you have all the values given above. For part B, all the values are given. I will show you. You can see W naught. You can see here W naught, W, L, E. Each and every value is given. So only the value of I, which will be taken from the appendix of the table, I will show you. This is W18 by 50, so it is 800 something. So again you have to put the value 800 inch 4. So when you put the value in this, so let me put y maximum is equal to 0.0065 0.00652 into W naught was 375 and length was 216 inch. Clear? Length was given in foot, so you have to convert it into inch. E is 29 into 10 to the power 6 and I was 800. So when you calculate it, it will be 0.229 inch and it will be negative value. So by negative means deflection is downward. So maximum deflection, the value of maximum deflection is 0.229 inch and that is downward. So this was the answer of part B. I hope you have enjoyed the video. since these videos are very lengthy, so in order to understand it, so you have to have a clear understanding that what is going on. Again, thank you for supporting me and watching my videos. Take care.